Welcome to Lecture 28, Section 7.2, Applications of the Normal Distribution. Okay, so if x is a normally distributed random variable, the area under the normal curve, okay, so if this is the curve, we're talking about the area underneath it. The area under the curve represents the proportion of a population with a certain characteristic, or the probability that a randomly selected individual from the population has the characteristic. Okay, so for objective 1, find and interpret the area under a normal curve. So that should be and. So recall, we can use the z-score to change x with a mean of mu and a standard deviation of sigma into a random variable capital Z with a mean of 0 and a standard deviation of 1. Okay, so for standardizing a normal random variable, suppose that the variable x is normally distributed with a mean of mu and a standard deviation of sigma. Then the random variable, capital Z, would be equal to our capital X minus our mean value divided by our standard deviation, which is normally distributed with mu equal to 0 and sigma equal to 1, or our mean of 0 and standard deviation of 1. The random variable z is said to have the standard normal distribution. So for example 1, finding the area under a curve. A pediatrician obtains the heights of her 10-year-old male patients. The heights are approximately normally distributed, with mean of 55.7 inches and standard deviation of 3.8 inches. What is the proportion of 10-year-old males that have a height less than 50 inches? Okay, so first for part B, draw a normal curve that depicts the problem. Okay, so we have our normal curve here. And what are we looking for? Well, we have a mean of 55.7, and we know we have standard deviation of 3.8. And we are looking for the proportion of 10-year-old males that have a height less than 50 inches. So let's say this is 50. And we want the proportion of males that are in the area below it. So less than 50. So what's our plan? Well, we're given the standard deviation and the mean, as well as the x value that we're looking for. So we're going to change this into the random variable z, and once we do that, we can then find the probability from our z-score table. And that table is located in the back of your textbook. I've taken small little excerpts from the text because I can't fit the whole table on each problem, but these are kind of what they'll look like, and I'll go over how to read that. Okay, so that's our plan. So we want to change this into a z-score. So we're going to use the formula z equals capital X minus mu over sigma. So that means z is going to equal, let's see, so capital X was 50 minus the mu, 55.7, divided by sigma, which was 3.8. And what are we going to get here? So we end up with z is negative 1.7. Sorry, number 1.5. And notice, so now we're using lowercase z when we're solving here. Okay, so lowercase z is negative 1.5. So we would go ahead and look at our chart, which I've taken a small excerpt here, and we are looking for negative 1.5, and that's just it, negative 1.5, nothing after that. So negative 1.5 would be this one right here. So we can go ahead, we'll round that out. And one thing to note, this table that we're given, which is going to be table 5 in the back of your book, I've also uploaded it to your Laulima. This is talking about the area to the left of the item that you're looking at, okay? Area to left. So if we're changing the way we're looking at things, we might have to do a bit of fiddling. But always remember, this is the area to the left. So what is the probability? Well, it is 0.066, which we could round out. but we'll go ahead and leave it as the given decimal. So the answer is the normal model indicates that the proportion of the 10-year-old males who are less than 50 inches tall is, what did I find? It was 0.6681. Okay, so now let's take a look at example 2. For the pediatrician in example 1, find the probability that a randomly selected 10-year-old boy is taller than 58 inches. Okay, so first draw the normal curve that depicts the problem. Okay, so here's our curve, here's our mean, 55.7. Standard deviation was 3.8, and we're told we're looking for something higher or taller than 58. Okay, so 58, ooh, we're looking for something taller. So taller then would be to the right. Oh, that poses a small problem, because remember, our chart talks about area to the left. So we're going to have to fiddle with that in a little bit. But for now, let's first go ahead and translate this to a z-score. So that's going to be x minus mu over sigma. So z is going to equal our 58 value, which is the new x, 58 minus 55.7 divided by 3.8. And what do we get? Z is going to be approximately, okay, well, let's see. We're going to round our answer, but notice the way our tables are set up for table 5 is it only goes out farthest to the hundredth place. So we're going to go ahead and round to the hundredths, which would be 0.61. All right, now let's go ahead and find that. So 0.6 is up here, and then we're looking for 0.61. So that means we're looking for 1 in the hundredth place, which would be this column here. So they align right here at this point, or at this value, the proportion, 0.72907. Well, we might be tempted to say that's our answer, but remember, these charts are always giving us the value to the left. So the value to the left is the 0.72907, which is not what we want. We want the value to the right. So how do we find that? Well, we know the total area is 1, right? So to find that, we're going to take 1 and subtract away from it the 0.2907, and once we've subtracted this value away, the remaining area will be what we want. So let's go ahead and calculate that out. So that's going to be 1 minus 0.72907, which gives us 0.27093. All right, so what is our answer? The proportion of 10-year-old males taller than, what was it, 58 inches is 0.27093. Okay, so once again, always answer a word problem in word form. And as usual, the amount of work that I show in my problems is the amount of work I'll be looking for on your exams. All right, so example 3, finding the probability of a normal random variable. So for the pediatrician in example 1, find the probability that a randomly selected, and this should be 10-year-old boy, is between 50 and 61 inches inclusive. That is, find the probability of x being in between 50 and 61. So what are we looking for here? So drawing a picture first off. It's always good to get a visual. So once again, we have the mean of 55.7. That hasn't changed. But we're looking for the values in between 50 and 61. Ooh, how are we going to find this? In between 50 and 61. Well, first things first, let's go ahead and find the z-scores. And then from there, we can figure out how to manipulate it to find the area that we're looking for. So I'm going to go ahead and use, because we have two different values, we'll go ahead and call this x sub 1 is 50, and x sub 2 is 61. And notice, because I write it here, we're good. I don't need to include it anywhere else. So z sub 1 is going to equal my x sub 1 minus mu all over sigma. And z sub 2 is going to equal, actually I'll write that below. So z sub 2 is going to equal x sub 2 minus mu all over sigma. So let's write these out. So z sub 2 is 61 minus 55.7 divided by 3.8, and then z sub 1 is 50 minus 55.7 divided by 3.8. So what values do we get for our two z's? All right, so those are the values that we have. So we did find the z-score for this answer right here back in the very beginning, which was 0.6681. So I'll go ahead and write that down. So then the proportion for this is 0.06681. And that is the area to the left of 50. So that's this area right there. And then we're trying to find, so for 61, and I actually put the wrong chart here. So actually in your actual chart, you would go ahead and look for the 1.3. 1.3, we'd keep going until we found the column of 9, which would be further down. These are 0, 1, 2, and 3 column, which is not what we need. So when you find the actual column for 1.39, the answer for that would be 0.9177. And this would be the area in green, which I'll go ahead and just highlight outwardly here, because remember, it's the area to the left. So what do we want? We want the blue area. And how would we find that? Well, if we take the green area and then chop away the red area, we'd be left with the blue area. So let's go ahead and do that. I'll call this area 1, and that's area 2. So to find the area that we want, that is going to be area 2 minus area 1. So that will be 0.9177 minus 0.06681. Calculating that out, I end up with 0.85089. So that is the proportion we're looking for. So my answer is going to be the probability of a boy, a 10-year-old boy, being between 50 and 61 inches tall is 0.85089. Pretty high probability for a boy being in between those two height markers. Let me fix that box. Okay, so objective 2, find the value of a normal random variable. So often we'll want to find the value of a normal random variable that corresponds to a certain proportion, probability, or percentile that we're given. So basically, we're going to be solving what we did backwards. So oftentimes, we'll be given z, which is the proportion, and we'll want to find x, the value that corresponds to it. So for formula variations, we're given this formula here, which is the one we know before. And then here's some variations of this formula, and I'll go over how we found them. So for 2, we'll start with the formula we originally had, which is z is x minus mu over sigma. And we want to solve for z sigma. So if we multiply both sides by sigma, we'll end up with the formula sigma z equals x minus mu, which is the formula we have there. Again, we could manipulate the first equation to find the other equation here. We could go ahead and multiply both sides by z once again. Sorry, not z, sigma. And we'll end up with sigma z equals x minus mu. Then subtracting, or adding mu to both sides, we'll end up with our equation x equals mu plus z sigma. Okay, so those are how we get those equations we'll work with. Let's take a look at example 4. So, once again, looking at the pediatrician example, a pediatrician obtains the heights of her 10-year-old male patients. The heights are approximately normally distributed with mean 55.7 inches and standard deviation of 3.8 inches. Find the height of a 10-year-old boy in the 50th percentile. So now what are we looking at? Well, we're talking about the percentile, so let's see, we have our chart here. We're looking for being in the area of 50th percent. Okay, so 50. So the 50%. And we don't know what the x value is that we're looking for. So how are we going to do this? Well, we want to solve for our x value. And the formula for that is going to be this one. So x is mu plus z times sigma. Well, we already know mu, which is 55.7. We're given that right there. Plus, well, we don't know our z value yet, but we do know our sigma, which is 3.8 inches, or our standard deviation. So now what do we need to do to figure out the answer for this? In our table, we're going to look for the area that corresponds to 50%, which means we're going to be looking, instead of looking at these side columns, which we were doing previously, we're going to do the reverse. Now we're going to look at the proportions, or the percentages, and see which one matches 50%, or the area that you're looking for. And in our case, we're looking for 50. So the one that matches is this one right here. And that z-score value is a strange one, but it is actually just going to be 0, 0. So that'll be 0, which means x is going to equal 55.7. Does that make sense? Well, yeah, because remember, my mean was supposed to be 55.7. So that is the middle value. Alrighty, there we go. So let's see, the height of a boy, a 10-year-old boy, in the 50th percentile would be 55.7 inches, which also was our mean, because that is exactly half of the height. That makes sense. All right, so example 5, finding the value of a normal random variable. So the reading speed of 6th grade students is approximately normal. Okay, so that's an important thing to note. It is approximately normal, which means we can use these different methods. We can change our x value into a z value to find a z-score, which is a lot easier. So let's see how we're going to do this. So with a mean speed of 125 words per minute and a standard deviation of 24 words per minute, what reading speed separates the middle 90% of readers from the bottom and top 5%? Ooh, what are we looking at here? So if I draw a little drawing of our normal curve, that was not pretty. We're looking for the middle 90% readers from the top and the bottom 5%. So the middle 90%. So the top and bottom 5%. I can go ahead and write those here. So that's 5%, and that's 5%. So we are looking for those distinction areas right here. We're looking for these x values that mark that split point between the 5% and the 90%. So we're looking for the x1 value and this x2 value. So how are we going to find them? Well, we're looking for 5%. So we're looking for the area less than to the left of 5%. So on our map here, remember all these areas, oops, wrong pen. All of these values here are the area to the left. So we're looking for 5%, which would be 0.05. Now what we're going to do is, because we're not going to find the perfect percentage for 0.05 here, so let me write that down. We're looking for 0.05. We're just going to look for the things that are closest to it and then take the average between the two. So let's find the value above 0.05 and the value right below it. So the value right above 0.05. So we see actually that the 0.05 is there, and what I forgot to do, I did not include the other endpoint here, but it goes on in your chart to 0.0495. Okay, so we're looking for the average because it's not perfectly giving us 0.05, so it's in between these two numbers. That's the percent that we're trying to find, or that's the percent we have. So the corresponding z-scores for each of those are, we have 1.604. Okay, so we have negative 1.64, and we're going to take the other one, which is also close, which is negative 1.605. So plus negative 1.65. And we're going to take the average to find the closest z-score. Let's go ahead and calculate that out. That'll be 1.64 plus 1.65 divided by 2 gives us about negative 1.645. So that is our z-score value right there. Now that is the area to the left. So this right here is when I rewrote my normal curve in terms of x. I'm going to go ahead and rewrite it. So this was x. So let's look at z. And remember, when we translate it to z, we have a mean of 0, right? So this value here was negative 1.645. And we want the exact reciprocal reflection of that value for the other area. Because remember, we're trying to find those two areas, the red side and this area right there. We're trying to find those outliers that are not in the 90%. So that is going to be the mirror of negative 1.645, which is going to be 1.645. So the exact mirroring of each other. So to find these values, so for x1, it's going to equal our mu plus z1 sigma. And that's our z1, and then our z2. So x1 is going to equal our mu value, which is 125. 125 is the mean, plus our z, which is negative 1.645, times our standard deviation, which is 24 words per minute. And then we get x1 equals, and we get 85.52. So that's this value, 85.52. When we translate back from being in the z-scores to being in the regular x for the random variable, and then let's go ahead and find x2, which is going to be mu plus z sub 2, and standard deviation would be 125 plus, and then we're using 1.645, because remember, we're looking at the mirror image or the reciprocal. Because this whole thing is symmetric, we can assume they're the same. And then what do I get when I multiply this out? So I have 1.645 times 24 plus the 125, and I get, 164.48. So that would be my x2 value. And what would I translate this as for my answer? Well, let's see. The 5th percentile, the students would be scoring 85.52 words per minute. And then students in the 90 plus 5, so 95 percentile, would be reading at 164.48 words per minute. So let's write this out. Let me go ahead first and move this over a little bit so I have some space. Let me erase any of the duplicating there. All right, so for my actual answer here. So we were saying the x sub 1 was 85.52, and those are the students that are in the 5th percentile. So students in the 5th percentile read 85.52 words per minute, and students in the 95th percentile read 164.48 words per minute. And that's just one way to sort of interpret the answer for this problem. So now some notation. So the notation z sub alpha is a z-score such that the area under the standard normal curve to the right of z sub alpha is alpha. Okay, so let's take a look at this. Find the value of z sub 0.24. So what are we looking at here? We're trying to find the area. Let me go ahead and draw a little graph here. We're trying to find the area if we have our mean. Now notice, this is talking about z-scores. So what's the mean for z-scores? Well, it's going to be 0, and our standard deviation would be 1. So we're looking for the area to the right of 0.24. So in reality, that'd probably be a lot closer. It'd probably be about here, 0.24. Okay, so we're looking for that area to the right. Now, how would we find this? Well, we know with our table that we're given, these are all areas to the left. So how would we figure this out? Well, if we subtract the 1, the whole area, and then take away the 0.24, we could find out the area to the left. So subtracting away, what do we get? We get 0.76. Okay, so let's see. That means that the area to the left would be 0.76. So let's go ahead and search our chart for 0.76. And then the value that corresponds closest to the 0.76. So let's for that 0.76, closest one. So it'd be in between these two. So 0.70 and 0.71. So we'll go ahead and take the average of those two. So let's see, 0.7 plus 0.71, divide that by 2, and we'll get 0.705, which, depending on how they want you to round out, would possibly be about 0.71 if you're rounding to the hundredths place. So what is our answer saying? Well, our answer is saying that the z value that has an area to the right of 0.24 is going to be 0.71. So that is the z value that has the area to the right being 0.24. Right, and that is it for this section. Please email me if you have any questions.